Okay, so this is the H&R diagram tutorial video. In here, you're gonna find this file where you find a few tables and instructions on how to use the software. It's very conceptual. It's not like Stellarium where you have to really click and look into different parameters. You're just gonna be looking at certain classifications of stars in the H&R diagram based on luminosity, temperature, and radius, the diagonals, and of course, the classifications. The first question can be done by using the textbook or even Google. The surface temperature of Betelgeuse, they already give you the spectral type here, and the color, so you can just Google Betelgeuse. And it will show you the classification, the temperature, and for the color, I mean, you can just look at an image. It's a red giant, right? You can look at NASA websites, or you can just look for the wiki. And it says there is a red supergiant. So that's how you can look. You can also use Stellarium, but I don't think you can find the temperature in there. So if you want to look at the classification, it's given in Stellarium, the color as well, but not the surface temperature. So for example, Sirius A, it's a main sequence star, blue, white, the temperature there. So that's an easy table to fill in. For this table, you just have to use this equation where luminosity is basically r squared t to a 4. So 1, this will be 1. If radius is 1 squared is 1. Temperature is 2 to a 4 is 16. So this will be 16. Okay, so it's just a proportionality. You can use this as an equation to fill this table. And the same here. So L proportional to N to the 3.5. So mass, 2 times of mass of the sun will have a luminosity. So this means luminosity of the sun, mass of the sun. Okay? That's what that means. So if you go to look at the calculator, 2 to the 3.5 is 11.3. So that I will give you the answer here. And you will have to do the opposite here for the luminosity and then find the mass. Okay? You have to take the root of this value. Okay? So it's just to show you some relationships. Here is where you're going to use the software. So they give you some descriptions here and this table. And then you have hot star, faint star, luminous, cool. Look, you're going to watch my lecture on this, but pretty much you have the luminosity scale going up, the temperature scale going up towards the left. So stars that are very hot, very luminous are here. Normally blue giant stars. This is the main sequence curve, where here you find red dwarfs, like for example, Proxima Centauri. This will be the sun with a luminosity of 1 because that's 1 times the luminosity of the sun, and a temperature of about 5,800 kelvins. You have the luminosity class here, supergiants, giants, white dwarfs, red dwarfs, and the instability strip. And then if I click this off or on, you can find the radius. So that's the size of the star. So I start with the radius of the sun is there. 10 times the radius of the sun is here. So those are your giants here, okay? And then here you have your supergiants, 100 times the radius of the sun, 1,000 times the radius of the sun, okay? Yeah, this will be super red giants, by the way, right? Antares will be around here. It's a supergiant star. So that's basically what you have to do here. Like hot stars, just look at the scale. Faint stars, look at the scale. They will be like with a low luminosity. Luminous, high luminosity. Cool stars with low temperature. So that's actually very easy to fill in. Large blue, small red. Large blue, small red, right? So that's basically how you do it. Then here they give you the equation for luminosity. You want to explain what you found on this table based on this. So luminosity increases as the radius increases and the temperature increases. So just look at the high luminosity for a giant or super giant star with a very high temperature and then go all the way down. Here, you still have a relatively large star, more luminous than the sun, but less luminous than a giant here, blue giant here. So you can explain that based using the equation here. Describe the size of the stars along the main sequence. So the main sequence, remember, is this curve. So you can go from maybe here to here, right? That's still a main sequence. So you want to describe what type of stars you find around here, here, and then here, in terms of their temperature, luminosity, and even the luminosity class. Another equation that you have to explain now in terms of the mass. What can you say about the mass in terms more luminosity, more mass? So you can take a look at the H&R diagram and see and write a conclusion. Then question 5 is where you're gonna draw your own H&R diagram. Follow these instructions, like draw green on the x-axis, draw red, an arrow showing the direction of the increasing radius. So increasing radius, like this, right? So you want to show the arrow indicating. It's basically looking at this and making a more descriptive type of diagram. It's nothing difficult, all right? Then you want to analyze the instability strip. That's where we find Cepheid variable, for example, right, this here. That's important because we use those stars for distance values to calculate distances in the universe. Okay, so we use Cepheid variables, for example. There is a whole equation that we use and a whole procedure and observations. So you wanna check this. You can also click here, by the way, and it shows you nearest star, brightest stars, nearest and brightest. So you have, as you can see, there are much more red dwarfs that we have found than super giants or giants even here, right? Oh yeah, so here, check the plot stars at nearest stars. You should cover, yeah. So describe the characteristics of the nearest stars. So that's just the nearest stars. So look, they are mostly here, right? Proxima Centauri is the best example for that. Do you think these stars are rare or very common? I mean, you can take a look based on the diagram here, right? If they're common or not. And check the plotted stars option, the nearest stars, and check the brightest stars. So we go now to the brightest. And there. And that makes sense, right? They have to be giants or supergiants. Obviously, not as many as here, but still quite a few that we can actually classify. So it's very qualitative. Okay, it's very qualitative. The idea with this lab is just for you guys to use the H&R diagram and describe what you see. Okay? For the plot, by the way, you may want to Google a few stars or maybe use Stellarium and take a look at Antares, which is a super red giant. You can use Betelgeuse, Sirius A, Alpha Centauri, Rigel, which is a blue giant, Bellatrix as well. You can use Proxima as a red dwarf, okay? And then for white dwarfs, Sirius B, okay? You can use Vega as well for a main sequence. So use those so you can actually make a good plot for question 5. Okay, that probably is going to be a question that might take you a bit more of time to do. But other than that, the lab is relatively simple. Okay, the suggestion is to type your answers in blue so I can actually easily grade your submission. Okay. Thanks to Dr. Ganapati, Preeti Ganapati, she developed this lab. I made some changes here and there, but most of it is or was developed by her. So make sure you send any questions to me. But I think this video should clarify anything related to this lab. So without further ado, guys, I'll see you guys on the next video and have a nice rest of your day.